Greetings, aspirants. Today, we are going to talk about cryogenic engine technology. What do you mean by cryogenic? Cryogenic is nothing but at low temperatures, at cryogenic temperatures. As we all know, we have started to we have started to inculcate the cryogenic technology through the GSLV launch vehicles. Initially, we got this technology from Russia, but later we developed our own indigenous cryogenic technology. Firstly, why should we use cryogenic technology? Because it provides more efficiency and provides more thrust for every kilogram of fuel burned. For this reason, like we can put payloads of more mass in the orbits. Also, the specific impulse, which is nothing but the measure of efficiency. Which is nothing but measure of efficiency of the launch vehicle with cryogenic propellancy is much higher compared to earth storable liquid and solid propellants, giving it a substantial payload advantage. As I told you, this is going to give us a payload advantage, and we can place payloads of much higher mass into the intended orbits. We have to know that technically it's a very complex system because we are using the hydrogen and oxygen, liquid hydrogen and liquid oxygen, LOX and LOH2. This is since we are using this at a very low temperatures, cryogenic temperatures, this involves a complex system, and also this associated thermal and structural problems. We have associated thermal and structural problems. Moving forward, we have to know that our oxygen liquefies at minus 183 degrees centigrade and hydrogen liquefies at minus 250 degrees centigrade. But why are we using only hydrogen and oxygen? Because the combination of hydrogen and oxygen is going to give you higher efficiency. This is the best combination for achieving a good efficiency, right? For this reason, we are going to use the hydrogen and oxygen. And second, this is going to give us higher thrust for the fuel burnt, because as more fuel is burnt, we are going to get more power or the more thrust. Okay, so the propellants at these low temperatures, the LOX and LOH2, are to be pumped using turbo pumps. They are using turbo pumps. We are pumped, and they are ran at around 40,000 RPM. Okay, they are ran at around 40,000 RPM, and this is going to give us the high mass flow rate, which is required to burn the fuels. Also, it entails complex ground system support, because we have to carry these liquid oxygen, liquid hydrogen. So we need like propellant storage and filling systems, cryogenic engine and stage test facilities. Also, it's very difficult to transport. So we are going to face such difficulties. But why are we facing such difficulties? Because it's going to give us a significant advantage. It's going to give us a payload advantage. And also, as I told you, it's very efficient compared to solid and liquid fuels. So the latest ISRO's cryogenic upper stage project envisaged the design and development of indigenous cryogenic upper stage to replace the stage which was procured from Russia. And the main engine and two smaller steering engines of the CS together develop a nominal thrust of 73.55 kilonewton in vacuum. During the flight, this CS fires for a nominal duration of 720 seconds, right? As I told you, this liquid hydrogen and oxygen we are using in cryogenic form, because in cryogenic form we are going to get maximum thrust. From the respective tanks are fed by individual booster pumps to the main turbo pump to ensure high mass flow rate, as I told you, of propellants into the combustion chamber. So the higher the flow rate, higher the pressure, higher the force we are going to get. This thrust control and mixture ratio control are achieved by two independent regulators. Two gimbal steering engines provide for the control of the stage during the thrusting phase. So this liquid hydrogen, liquid oxygen are used for the cryogenic stage, and through this we have got a significant payload advantage, and we have increased the power or the thrust which is required to put the payloads into the intended orbit. So in this video we saw about the cryogenic engines, what is the purpose for bringing it, and what are the like significant steps involved in it, and what are the advantages we are going to get through the cryogenic technology. We'll be back again with the next concept. Thank you.